All right, so now we're ready to take this solving systems situation one step further, and we are going from solving a system, 2 equations, 2 variables, to 3 equations, 3 variables. You need as many variables as you have equations, okay? So if we had a system of 5 equations, and yes, they exist, you would need 5 variables. So when we solve a system of 3 equations, 3 variables, we don't get an ordered pair. We end up with what we call an ordered triple with an x, a y, and a z. An ordered triple being a solution means the exact same thing as it did for an ordered pair and a solution to a line. If I check to see if that point is a solution to this equation, it simply means if I plug in the x, the y, and the z, does it make the equation true? So let's see, 6 minus 0 minus 21 equals negative 15. 6 minus 21 is negative 15 equals negative 15. So what I just discovered is that this point lies on the graph of this equation. So now, let me quickly remind you that when we had a system of 2 equations, 2 variables, there were 3 solutions that could possibly happen. They could cross in one point, so that meant that there was one solution. Remember, they could be parallel, which meant that there was no solution. Or they could be the exact same line, which meant that there was infinitely many solutions. When you graph or you look at a picture of an equation that has 3 variables, you do not look at a line, you are looking at a plane. So let me remind you, a plane visually is like a tabletop, but it goes on and on in all directions. We graph on a coordinate plane. If I look at this, remember this was called the coordinate plane, and remember it was filled with a bunch of points, and the arrows meant it went on and on forever when you first start talking about graphing points. This is called a coordinate plane. So we represent the coordinate planes just like this. Now I know this is dark, but I cut and pasted it. It came out dark and there's really nothing I can do about it. But here are 3 different things that can happen. Now, all 3 of these pictures means that there is no solution to the system. If you look at here, you're looking at a place where the 3 planes are parallel. Obviously, they do not all cross at one point because, again, if you're looking for a solution to the system, you're looking for a point or points where all 3 planes cross. If we're looking at this picture, now you notice actually here, 2 of the planes cross. Here, 2 of the planes cross. And here, 2 of the planes cross. But is there a place where all 3 planes touch? The answer is no. That would be another no solution. Look at this one. Another situation that can happen. Look, these 2 planes are parallel, and this one cuts through. And you can see that these 2 planes cross, and these 2 planes cross. But is there a place where all 3 of the planes touch? Absolutely not. So all of these situations would yield you a no solution. But let's look at the 3 pictures on the next page. All 3 of these pictures give you a solution to the system. But the solutions look a little bit different. If you look at this picture, you can see the 3 planes. Here's one, the lightest one, then the medium colored one, and the darkest one. If you look, those planes touch in exactly one point, one ordered triple, and it's right there in the middle. And that's what's going to happen most of the time when you are asked to solve a system of 3 equations with 3 variables. If you look at this picture, do you see where all 3 of these planes cross, but they don't cross in a single point? they actually cross in a line. Because remember, they keep going on and on forever, so they cross in a single line, so it doesn't always have to be a single point. And then if you look at the third picture, well, what this means is they all happen to be the exact same plane. Just like we had the solution where it was two lines with the same line, these would be all the exact same plane, which means that they would cross in infinitely many points. They would cross in all points that lie on the plane. So those are the three possibilities that could happen to get a solution to your system. Now, the key to these is going to be for you to stay organized, and you're probably going to have to watch this video a couple of times. First of all, let me tell you, there's probably 8, 9 different ways to solve each one of your systems when you have 3 equations, 3 variables, just like there was probably 4 different ways for you to solve a system of 2 equations, 2 variables. There's usually an easiest one. So here, the first thing that you have to decide is, I need to eliminate a variable. I need to eliminate a variable 2 different times. I need to eliminate the same variable 2 different times. So if I go down and if I look at my x's, my y's, and my z's, do you see that if I were to add these top 2 equations, I would eliminate the z? Now again, you could eliminate x's, you could eliminate y's, it doesn't matter. But it just looks to me like the z's are going to be the easiest one. So you have to stay organized. I like to call my 3 equations A, B, and C. Okay, so again, I've chosen to eliminate z. I have to do it 2 different times. Let's see what that's going to look like. The first thing I'm going to do to eliminate my z is I'm going to add a and b. If I add a and b, I'm going to get 4x plus y, the z's disappear, equals negative 14. And I'm going to put a box around that because I'm going to have to come back and find that in a couple of minutes. Now, so I've eliminated the z using equations A and B. I need to eliminate the z, the same variable, again. And I can't use A and B. I've already done that. So I could eliminate the z using A and C, or I could eliminate the z using B and C. It does not matter. I think I'm going to use A and C. So do you see where if I'm going to eliminate and I want these to drop out, I'm going to have to multiply equation A, the top one, by 2. Because then this is going to be 2z and this is going to be negative 2z, and they will drop out. So I'm going to do 2 times equation A, which is going to give me 6x minus 2y plus 2z equals negative 30. And I'm going to add that to equation C, which is 2x plus 3y minus 2z equals 0. And when I add these, I'm going to get 8x plus y is equal to negative 30. So now look what I have just done. I've eliminated the z twice. In essence, what I've done is I've taken my 3 equations, 3 variables, and I have turned it into 2 equations with the same 2 variables. So now I'm back to using substitution or elimination like I did in the first part of chapter 4. So I'm going to go over here and I'm going to rewrite my 2 equations. And this is why I box them, by the way, because I need to find them to be able to use them. So now, again, here I can go ahead and I can use any method that I want. I'm thinking that I'm going to multiply the top equation by negative 1, because then my y's are going to drop out. So I'm going to get negative 4x minus y equals 14. If I add these two equations now, I'm going to get 4x equals negative 16. That's negative 30 plus 14. So x is equal to negative 4. I found my first of my three variables. Now the good news is your work is 80% of the way done, because now it's just a matter of plugging the values in as we go up the equations to solve for the other two variables. This is the hard, we just did the hard part. So now once I have my first variable, I can go up into either one of my two boxed equations to find my second variable. It doesn't matter which one. I'm just going to go ahead and go into this one. So 8 times negative 4, because I just have my x, plus y equals negative 30. Negative 32 plus y equals negative 30. And if I add 32, you can see that I'm going to get a positive 2. Okay, so there's that one. Now let's go ahead and let's find our z. We have to go up into the top equations to find our z, any one of those three. So I think I'm going to go into the middle one. So I have x is negative 4. So I'm going to have negative 4 plus 2 times y. So that'd be 2 times 2 minus z equals 1. So negative 4 plus 4 minus z equals 1. Well, those drop out. I get negative z equals 1. So z is negative 1. So my ordered triple will be negative 4 to negative 1. So again, that's the solution. That is the point, the x, the y, and the z that fit into all three of these equations. That is the point where if I were to graph these three planes, that would be the one single point where all three planes would cross. So it's a lot of work. Stay organized. That is the key. We're going to do a few more. All right, let's do this one. So here we go. So again, you want to take and you want to eliminate the same variable twice. As I look down my coefficients for my x's, my y's, and my z's, it kind of doesn't look like there's any one that's any easier than the other ones. So it's kind of up to you. I think I'm going to go with the x's, and I'm going to eliminate the x's. So if I call this equation A, this equation B, and this equation C, I have to eliminate the x's twice. So if I go ahead and if I use equation A and B to eliminate the x's, I'm going to have to multiply the top equation by negative 2. So I'm going to do negative 2 times A. So that's going to be negative 2x plus 4y minus 6z equals positive 6. And then I'm going to leave equation B untouched. And now when I add, the x's are going to disappear. I'm not going to do that. So this would be minus 7z equals 13. And I'm going to box that. All right, so now the key is I have to eliminate the x again. I think I'm going to use equation A and C this time to eliminate the x. So I'm going to multiply equation A this time by negative 3. So that's going to give me negative 3x plus 6y minus 9z equals 9. My equation C is going to stay the same. Now I'm going to add. Notice the x is going to disappear again, which is exactly what I wanted. And I get 7y minus 11z equals 15. Numbers are not ideal here. All right, so notice what I have now. I have two equations with the same two variables. So I'm just going to quickly rewrite those equations right here. So y minus 7z equals 13, and 7y minus 11z equals 15. So now I have to go ahead and I have to eliminate either the y or the z. I think I'm going to eliminate the y by multiplying this top equation by negative 7. So that's negative 7y plus 49z equals negative 91. Yikes. So the y's are going to disappear. 49 minus 11 is 38z equals, I'm going to use a calculator so I don't make a stupid mistake. I get negative 76. Ooh, life is good because look, z is equal to negative 2. I would never give you a system of 3 equations, 3 variables that turned out to be an answer that was a fraction. That would be terrible. So now remember, most of our work is done. Now we just kind of move our way back up the problem to find our other variables. I think I'm going to take and I'm going to plug this into here. So y minus 7 times negative 2 equals 13. Y plus 14 equals 13. Y equals negative 1. And then to find my last variable, I have to go up into one of the top equations. I think I'm going to go up into the top one. So I'm looking for x minus 2 times y. That's going to be plus 2. Plus 3 times z would be minus 6 equals negative 3. Whoops, you're not seeing that. So this would be x minus 4 equals negative 3. So x is going to be 1. So my ordered triple is 1, negative 1, negative 2. All right, I think I'm going to stop this video and go to a part 2 for our last 2 examples.